Okay, so we are going to rewrite each complex number into polar form. It is giving us a requirement that your argument is between 0 and 2 pi. So remember that polar form is r times the cosine of theta plus I times the sine of theta. So for 1 plus 1i, we have a is 1 and b is 1. So the first thing we're going to find is the modulus of this complex number, which, as you hopefully remember, it is the distance from the origin. So we end up square rooting a squared plus b squared. So in this case, it's the square root of 1 squared plus 1 squared. 1 squared is 1, so 1 plus 1 is 2. So our modulus is going to be the square root of 2. In order to find your argument theta, we take the inverse tangent of b over a. So again, in this case, we have b is 1 and a is 1, so 1 over 1 is 1. So we're essentially asking for what angle has a tangent equal to 1. And we know that that happens in the first quadrant at pi over 4, as well as in the third quadrant at 5 pi over 4. So our last job is to just pair this together and figure out what goes together in your final form. So we know that your modulus is the square root of 2, and it will be times the cosine of, now we have to choose the correct theta here, because we wrote down all of them between 0 and 2 pi that have a tangent of 1. So let's think about if we were to graph 1 plus I on the complex plane. On the real axis, we would go over to 1, and on the imaginary axis, we would go up 1. So your point would be over here in the first quadrant. So the angle that corresponds to that is going to be pi over 4, since pi over 4 is in that first quadrant. So we will use the cosine of pi over 4 plus I times the sine of pi over 4. Let me do one more of these. So I'll jump over here because this one's a little bit more challenging. If we're going to find the modulus here, we have to take the square root of negative 4 root 3 squared plus negative 4 squared. To square negative 4 root 3, remember that's negative 4 root 3 times negative 4 root 3. Well, negative 4 times negative 4 is 16, and root 3 times root 3 is 3. So 16 times 3 is 48. And the negative 4 squared is 16. So 48 plus 16 is 64, and therefore the square root of 64 is 8. So your modulus is 8 here. In order to find theta, we're going to take the inverse tangent of negative 4 over negative 4 root 3. So if we were to simplify that, negative 4 over negative 4 is 1. So this is 1 over root 3. So this is the same thing, if we were to rationalize that, as root 3 over 3. So we need to list out angles that have a tangent of root 3 over 3, which we know would be pi over 6 and 7 pi over 6. So our last job is to rewrite this. So our R value, our modulus, is 8, and it would be times the cosine of, now if we were to plot this in the complex plane, we would go left and down. So we'd be down here in that third quadrant, which means that we're going to choose 7 pi over 6 for our angle. So plus I times the sine of 7 pi over 6, and this would be our final answer.